Hello my gems, welcome to our week 1 video 2 notes. So today we're going to be talking a little bit more about trig functions. So this follows along with that video 1 week 1 that you did just a few days ago. I don't know if I told you guys this in the last video, but as you're going through, you have an option of taking these notes just by hand on with lined paper. Or you can actually go into our Microsoft Teams account, and if you click on the button at the top that says Files, you will see I have posted these notes in that week 1 folder along with my answer key for these notes and the homework. So you actually, if you have a printer at home, you can take these notes and you can print them off and you can follow along with me that way, if that makes it a little bit easier for you. If not, and you prefer to just do it on lined paper, that's also okay. You can do that, but that option is there for you. So I want to make sure that you know that you can reach it. So again, that's Microsoft Teams. If you go up top to the files, you'll see a week 1 folder. It's going to have everything you need in there, all the notes, all the videos, everything in there. Okay, so we're going to recall from our last video, we had 6 different trig identities that we talked about. And if you remember, this was the SOHCAHTOA. And then we also had our reciprocal identities, right, which took the sine, cosine, and tangent, and it just took the ratios and it flipped the ratios for cosecant, secant, and cotangent. So sine was opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent was opposite over adjacent. Right, so that was SOHCAHTOA. Those are 6 that you remember. And then the other ones are the reciprocals, so we just take the 2 ratios, the 2 terms, and we flip them. So cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotangent is adjacent over opposite. So it's important to know those 6 trig functions in order to do the problems that we're going to do today. So our first part that we're going to do is we're going to find a missing side length using some of those trig identities. So the first thing that you want to do is you want to make sure that your calculator or your phone is in degree mode. So if you're using your phone, you want to make sure it's turned off of the portrait orientation, right? So that you can turn it to the side and flip it like this. You'll know that it's in degrees if you see RAD at the bottom here. That means it's automatically set to the degree mode. If you're looking on if you have a calculator that looks like this, the Texas Instrument one, at the bottom here, you should see DEG, degree. You need to make sure you are in that right way, otherwise your answers are not going to come out to be the same as ours, or the same as mine. Okay, so it doesn't matter which one you choose to use, I'll show you how to use both of them. Okay, so example 1. A fire truck has an 84-foot ladder extending against a building, forming a 55-degree angle with the top of the truck. The truck is 8 feet tall. The firefighters are trying to reach a window that is 75 feet above the ground. Will they be able to reach the window using the ladder set at this angle? Okay, so we've got ourselves our picture here. I've got a right triangle. Okay, here's my 90 degrees. I know that down here I have a 55-degree angle. And remember, in the last video, we colored that angle and we marked it. We called that our reference angle. So you want to make sure you do that again as well over here. Now I'm going to label my sides. Across from the 90 is the hypotenuse. Across from the 55 is my opposite. And then next to the 55 is my adjacent. Okay, I know that this truck right here is adding an additional 8 feet because it's an additional 8 feet tall. So that's going to help me when I get to the end of the question. What I'm trying to find is this length over here. I want to know, do I have enough length over here to reach up 75 feet? So this is going to be my X, this side, the one that I'm trying to figure out. So now if you look at what's marked for you in the picture, you know the hypotenuse is 84, and you're trying to figure out what the opposite is. So if you're going to use hypotenuse and opposite, that means you're going to want to use the sine trig function. So we're going to write it as a ratio here, okay? I'm going to say the sine of my reference angle. I'm not going to put theta this time. This time I'm going to put 55 degrees because that's my angle measure, equals opposite over hypotenuse. So opposite is x, hypotenuse is 84. Cool. And from here, I'm just going to solve for x. So this is x divided by 84. To get rid of divided by 84, I'm going to multiply both sides by 84. Okay, right? Because whatever I do on one side of the equation, I have to do to the other. So my 84's cancel. I'm left with 84 times the sine of 55 degrees equals x. And now from here, I just have to put that into my calculator. So let me show you how we put that into our calculators. So if you're using your phone, you're gonna kind of go backwards here. In order to put in the sine of 55, you're gonna have to put the 55 first. So I'm gonna do 84 times, and now I'm not gonna put sine of 55, I'm gonna put 55 sine. You should see a little sine. Oops, I'm sorry, I pushed the wrong button. Look at me, Mr. Masso. 84 times 55, and then the sine button equals about 68.81 feet tall. So I know right now this length is approximately 68.81 feet. Okay, if you're going to do it on a calculator, you're going to do it, it's a little bit different. So you're going to do 84 times, and then you're going to put in sine of 55. So if you've got a calculator that goes this way, you can actually just go straight forward. If you're doing it on the phone, it's a little bit different. But I get the same answer, 68.81 feet. Great. Now, this length right here is 68.81, but I have to remember that the fire truck is already 8 feet up in the air. So it's already giving me another 8 feet. So this is the truck itself, and I need to make sure that I add those together. So when I add those together, I get approximately 76.81 feet is how high up the ladder is going to go. They're trying to reach somebody that's 75 feet in the air. 76 is greater than 75. So yes, my ladder will reach the window, right? Because 76.81 is greater than 75 feet. And there's my answer for the first problem. Okay, second one. The sun shines at a 60-degree angle to the ground. How long is the shadow cast by a 20-foot tall flagpole? Okay, so here's my flagpole, right? Here would be the shadow of my flagpole. And here's where my right triangle comes in. So this is a 90-degree angle. I know that the flagpole is 20 feet tall. Okay. I also know that it shines at a 60-degree angle to the ground. So it's not going to be up here. My 60 degrees is going to be down here. Well, that 60 degrees is my reference angle. So if you want to mark that in some way, I highly suggest that. Now I'm going to label my sides. So across from the 90 is the hypotenuse. Across from the 60 is opposite. Next to the 60 is adjacent. I'm trying to find how long is the shadow. So that would be this length down here. This is my x. That's what I'm trying to find. So now I know the opposite side is 20. I'm trying to find the adjacent side. That's x. Which one uses opposite and adjacent? That would be tangent. So I'm going to use tangent. Okay. So tangent of my reference angle is 60. Tangent of 60 equals opposite over adjacent. So 20 over x. Now, This one's a little bit different. I still want to get the x by itself, so this is 20 divided by x. To undo division, I'm going to multiply. So I'm going to multiply the right by x, multiply the left by x. On the right, they cancel. I've got x times the tangent of 60 equals 20. Now I still don't have the x by itself. This is x times tangent. So to undo multiplication, I'm going to divide. I'm going to divide by everything that's not x. So that means I'm going to divide by the tangent of 60. Whatever I do on one side, I have to do on the other. These cancel. I'm left with x equals whatever 20 divided by tangent of 60 is. Now I'm going to put that into my calculator. So if you're using your phone, okay, remember you have to kind of go backwards. So we're going to do 20 divided by, and I'm not going to put 60 tan, or excuse me, I'm not going to put tangent 60, I'm going to put 60 tan. 60 tan equals, I've got about an 11.5 foot shadow. And does that make sense? I've got a 20-foot pole and about 11.5% or 0.5 foot shadow. Yes, that makes sense. So that's how you do it on the phone. If you're doing it on a calculator, you're going to just put it in straight as you see it. So you're going to do 20 divided by tangent of 60. Close my parentheses, equals, I get the same answer. Okay, great. There's our first part. All right. Part 2, reciprocal identities. Let me zoom out. Here we go. Okay. An identity is an equation that is true for all values of the variable for which all expressions in the equation are defined. We've seen trig functions that include ratios that are reciprocals. So for example, I know that sine is opposite over hypotenuse. I know that cosecant is the reciprocal of this, which means hypotenuse over opposite. We can show that for all values of theta for any number that is an acute angle, I can prove that the sine of theta is equal to 1 divided by the cosecant. So here's what I'm going to do. I'm going to plug in my equation for cosecant. 1 divided by, cosecant is hypotenuse divided by opposite. Now, if you've got a number divided by a fraction, when you're dividing by a fraction, you really can multiply by the reciprocal, okay? So when dividing by a fraction, you can multiply by the reciprocal, right? So dividing by 1/2 is the same as multiplying by 2, right? Dividing by 1/3 is the same as multiplying times 3. So dividing by hypotenuse over opposite is the same as multiplying by opposite over hypotenuse. And 1 times the opposite is just opposite. 1 times the hypotenuse is hypotenuse. So you get opposite over hypotenuse, which is sine. So look at that. I just proved that the reciprocal identity is true. So these are called reciprocal identities. Whenever it's got that 1 there, it's true for all values of the variable. So let's do 2 together where we prove it on our own. Okay, so the first one says cosine of theta. Well, cosine of theta must be 1 divided by whatever the reciprocal of cosine is. The reciprocal of cosine, if I come back over here, reciprocal of cosine is the secant. So the identity is 1 divided by the secant of theta. Now I'm going to plug in. Secant really means hypotenuse divided by adjacent. And since I'm dividing by a fraction, I'm really going to multiply by the reciprocal. So I end up getting adjacent over hypotenuse. And cosine, SOHCAHTOA, right? Ka, the C-A-H, is cosine is adjacent over hypotenuse. And I'm done. I proved it. So now we're going to prove secant. So it's kind of just the reverse, right? Because secant means 1 divided by its reciprocal is cosine. Okay? Cosine is adjacent over hypotenuse. If I divide by a fraction, I'm really multiplying by the reciprocal. So I end up getting hypotenuse over adjacent. And secant is equal to the hypotenuse over adjacent, right? Oops. And there we go. So I just proved that these reciprocal identities are true. So that's where we get these 6 reciprocal identities that you see here. These are reciprocal identities that if I were you, I would highly suggest you write down. So you should be able to prove that all of those are true. All right, part 3. CoFunction identities. Okay, now, CoFunction identities are going to be as follows. There are identities that kind of work together with each other. So over here in this picture, I've got a picture of a right triangle. I've got one angle called theta, and I've got another angle called beta. It doesn't really matter what these are called. These are just some Latin terms here, but that doesn't really matter. I've just got 2 angles, right? Now, I'm going to look at each one of these angles as though it's its own reference angle. So I'm going to look from one angle to another. Now, if I'm looking at this first one, theta. Actually, before I do anything, you know what I'm going to write down on the side? My good old SOHCAHTOA. Because I want to make sure I'm doing everything correctly. Oh my gosh, do you hear all those motorcycles out there? That is so loud. Okay. So loud. All right. Now, the first one says the sine of theta. So if I'm looking from theta, as though theta is my reference angle, right? Sine means opposite over hypotenuse. So if I go opposite, I have a y term. If I go to the hypotenuse, that's across from the 90, I have an r term, right? Y over r. Now, if I look at the other angle, now I'm looking at beta. This is my new reference angle. Okay, I'm looking from this angle. If I look and I try to do the cosine of beta, cosine means adjacent over hypotenuse. So the side that is adjacent to this angle right here, I should really color code for you, right? If I go to the adjacent side, that would be y over the hypotenuse across from the 90 is r. So what you're noticing, I'm hoping, is as you look at those two, you go, oh my gosh, those ratios are exactly the same. However, they're 2 different trig functions. One's the sine and one is the cosine. Sine, cosine. Don't those kind of sound similar? One just has the word co in front of it. That's why they're called co-functions. You can kind of hear it in the name itself. Now, I know that this is a 90-degree angle right here, right? In a triangle, you always have 180 degrees, right? Inside of a right triangle or any triangle, right? It's always 180 degrees. That means if this is 90 right here, when I add up theta and beta, they should also give me 90 degrees, right? Because this plus this would be 90, and then 90 plus 90 is 180, right? So both of these angles, when added together, give me 90 degrees. So theta and beta are called complementary angles, right? Complementary means they add up to 90. Okay, so the angles are complementary. Now, because they are complementary, I can rewrite sine as a cofunction of cosine. Okay, so I can say that the sine of theta is equal to the cosine of 90 degrees minus theta, right? The cosine, right, is over here, right? The cosine is y over r, and it's 90 minus whatever this degree is would be what's left over for beta, because these two are complementary. So cosine, well, we can kind of put sine and cosine are cofunctions, right? So sine is the cofunction of cosine, right? You can kind of hear it in the name, sine and cosine, right? Okay, so now we're going to try a couple examples. We're going to write the cofunction identity if we were given a trig ratio. We're going to use that same picture up top. Now, first one here is cosecant. Cosecant. Okay, if I look, I guess I should use a different color here. Cosecant of theta means hypotenuse over opposite. Hypotenuse over opposite is cosecant. So I'm looking at theta. Hypotenuse would be r, opposite would be y. So it's r over y. Okay, now if I'm looking at, so this was the first one, this was theta, now I'm going to look at beta. Okay, if I'm looking at beta, I want it to have the same ratio. I want it to have r over y. So if I'm looking from beta, if I go r over y, r is still the hypotenuse, but y is the adjacent. So it's hypotenuse over adjacent. Hypotenuse over adjacent. Now, if I go back to my 6 trig functions that I know, which one is hypotenuse, which one is hypotenuse over adjacent? It is the secant. So, this one here is the secant of beta, So, secant and cosecant are cofunctions of one another. So I can write the cosecant of theta is equal to, its cofunction identity is secant of 90 degrees minus theta. That will give me whatever's left over, which would be beta in this particular instance, right? So this is substituting in for beta. Okay, now let's try the next one, letter B. Secant of theta. Okay, so secant means hypotenuse over adjacent. So if I come up to my picture, if I'm looking at theta, that's my reference angle. Hypotenuse would be r. Adjacent would be x. So it's r over x. Okay, that was my theta. Now I have to look at my beta. Okay, so when I'm looking at my beta, I want it to be the same ratio. I want it to be r over x. Now, if I'm looking from this beta, looking from this b, right? Looking from here, I want it to be r over x. R would be the hypotenuse. X would be the opposite. So it's hypotenuse over opposite. And then I go back to my functions and I say, okay, which trig function is hypotenuse over opposite? Bing. Oops, can't see that. Ta-da. Hypotenuse over opposite is cosecant. So, hence I've got secant and cosecant, right? Again, you can hear those cofunctions in the name itself. So, I can rewrite this as the secant of theta is equal to, its cofunction is cosecant. And then to get beta, I just take 90 minus whatever my theta is. Because that will give me what's left over, right? 90 minus theta gives me what's left over, which is beta, right? So these two have to add up to be 90. So adding these two up to be 90 is the same as taking 90 and subtracting one of them, okay? So there is my cofunction identity. So we have 6 cofunction identities. And so I'd love for you to take a moment and to write those down. You can kind of hear them within the names too, right? Sine and cosine are cofunctions. Tan and cotangent are cofunctions. Secant and cosecant are cofunctions, okay? So that's an easy way to kind of remember which one goes along with which. Okay, now, this is not in the actual notes if you printed them off, but I've added 2 more quick examples just to kind of add to it so that when you get to, when you get to your homework, you'll be able to complete. Okay, so this example says, find sine if 62 times cosine of 90 minus theta equals 18. Now, I say, okay, cosine of 90 minus theta, what's its cofunction? Well, cosine is the cofunction of sine. So instead of me writing cosine of 90 minus theta, I can substitute this in, because that's a cofunction identity, to just be sine of theta. And now I want to get sine of theta by itself because it's asking me to find sine of theta. So this is 62 times sine of theta. Well, in order to get rid of that, I'm going to just divide both sides by 62, right? And so on the left, what happens is my 62s are going to cancel. So I get sine of theta equals 18 over 62. And then I say, well, can I reduce those? And yes, I can. So I can reduce those to be, can divide them both by 2, right? So 18 divided by 2 is 9. 62 divided by 2 is 31. So the sine of theta is equal to 9 over 31, and you've solved your problem. Good. All right, last one. And this one kind of doesn't talk about co-functions, but I realized on my last video I didn't really have a calculator, so it was really hard for me to do these types of problems with you. And I think you guys might have been a little bit confused. So because of that, I'm doing just a normal trig function problem here to kind of help us out. Okay. So Mr. Masso is looking up at the top of a 104-foot building. She stands 28.2 feet away from the building on the ground. At what angle is she looking up at the building? So I'm going to take a moment. I'm going to draw myself a nice picture here. Okay, so here's Mr. Masso at the bottom. Here's my building that I'm looking at. Beautiful. Okay, so she's looking up at the building. So that means this is where my triangle is going to be. Here's the 90 degrees. Now, I know this building is 104 feet tall. I also know that I'm standing 28.2 feet away. So that's down here. The question's asking me at what angle am I looking up at the building? So essentially, I want to know, what is this reference angle? So that's the angle that's what I'm going to try and find. Okay. First thing I'm going to do is I'm going to label my sides. So across from the 90 is my hypotenuse. Across from the angle is the opposite. And next to the angle is my adjacent. Okay, so I know that the opposite is 104, and I know that the adjacent is 28.2. So I go back to my functions and I say, okay, which one uses opposite and adjacent? Well, that would be the tangent. So I'm going to use tangent for this problem. So I don't know what the angle is, so I'm going to keep it as theta. So I'm going to say the tangent of theta equals opposite over adjacent. So 104 over 28.2. Okay, now this was the part I think that some people might have been a little concerned with how to put it into their calculators. So here's what you're going to do first. You're going to divide 104 divided by 28.2. Okay, 104 divided by 28 point, oops, come on, Mr. Masso, divided by 28.2. Okay, you're going to get about 3.68 or 3.69, right? But I'm going to leave that whole really big number in my calculator. I'm just writing it down over here so I remember. Now, you're going to push the tangent, -1, the inverse tangent button of 3.69. Now, if you're doing that on your phone, that means you're going to push the second button, and then you should see sine, cosine, tangent with little -1s next to it. So you're going to push the tangent, and you get about 74.8 degrees. And I know that it's degrees because it's asking me for the angle. It's saying at what angle is she looking up at the building? Her theta, I'm looking up at the building at a 74.8 degrees. If you are doing that on a calculator, it's a little bit different. So if you're doing it on a calculator, you're going to push the tangent to the -1, the inverse tan, you're going to push that first. So you're going to push second tan, right? That's tangent to the -1. And inside of that, you're going to put your fraction. You're going to put 104 divided by 28.2, and you're going to close the parentheses. You're going to push equals, and you'll get about the same thing. So you can do it on a calculator, you can do it on a phone. It just is done a little bit differently depending on which one you're using. Okay, so now we have finished our week 1 video 2 notes. I'm going to take these notes, I'm going to put my answers that I just did with you. I take a picture of them, I'm going to put them online on Microsoft Teams. Again, if you go into the files, you'll see it in there. You'll go into the week 1 folder and you'll see it. And then now you are ready to do your week 1 video 2 homework, which you will see is going to be linked on for you. It's an online kind of question. I think there's 10 to 15 questions that you're going to answer. Use these notes to help you as you go through. And make sure you read the directions, because I believe that once you get started on this online kind of, I don't want to say assessment because it's not an assessment, but once you get started on this online component, you cannot stop and you cannot come back to it. So definitely make sure if you're going to start it, you've got plenty of time to get it done. Okay, thank you so much. You are done with our first week of digital learning. This is awesome. If you have any questions, please feel to reach out to me, and have a great day.